For this video, we're going to talk about translations, which is shifting left, right, or up or down, and reflections, which is just basically a mirror image. So we're going to look at different functions and how that works. So here's a graph of the same function, just written twice. When we say the graph of f of x, we just mean the same thing as y equals f of x. That's what that means. And we can get into a function, what this function actually is. I think it's x squared. And the same for both of them. We're going to look at what the sketch of the graph of x plus 2 is. F of x plus 2. As opposed to f of x plus 2. Where the 2 is located is important. This 2 is associated with the x. So conceptually, I'm going to try to show you how this works, and then I'll show you some shortcuts at the end. Okay, we're saying this graph that we're going to graph now, I'm going to do this in red. I'm going to say y equals f of x plus 2. Now remember how functions work. F of x plus 2. So if x is 0, then I'm going to look at the function f and make 0 plus 2 is 2. So it's the same thing when x is 0. I'm going to have an ordered pair 0. And then the height of that will be whatever f of 2 is. Well, f of 2 is the function here at 2, which is 4. So 0, 4 is one of my ordered pairs for this new graph. The new graph, now when x is, let's say when x is negative 1. So negative 1 plus 2 is 1. So the height will be f of 1, which is 1. So when x is negative 1, we're at 1. What about x is negative 2? Negative 2 plus 2 is 0, so the height will be the same as f of 0, which is 0, so it looks right here. And if I continue, let's say negative, so this is going to be 0. What if I said negative 4? I would put in negative 4 plus 2 is negative 2. At negative 2, the graph is at 4. So that becomes up here to 4. And if I sketch the graph of this, I'm noticing it looks pretty much the same graph. It's just shifted over 2. And I'm noticing the difference. It's shifted 2 to the left. So this is positive 2, which just means we're going to shift it the opposite direction of this. So this would be shifted to the left 2 units. So if this were negative 5, I would shift it the opposite of negative 5, which is positive 5, to the right. So that's really all that is. Now this graph is a little bit different in that the 2 is not associated directly with the f of x. It's basically y equals f of x plus 2. So again, I'm going to do the same thing. 0, if x is 0, my new answer is going to be, that's supposed to be f of x. I put in f of 0, which is 0, and then add 2, and it just looks right there. Now, what if I put in 2? When x is 2, the graph becomes f of 2, which is f of 2 is 4, and then plus 2. So 4 plus 2 is right there at 6. What if I put in negative 1? F of negative 1 is 1, and then plus 2 is 3. And what happens is this graph looks like this. And it's the same graph, just shifted up 2. So in the y direction, this one here, it just, up 2 units. So this one goes the same direction. If it said f of x minus 3, I would shift the whole graph down 3. So the concept is a little confusing in that when it's inside the parentheses here, it goes the opposite direction. This is plus 2, I'm going to the left, which would be negative 2. This is plus 2, I'm going the same direction, which would be up 2 in the y direction. Okay, let's see if that makes any sense for this one here. It says, which transformation of y equals f of x moves the graph 7 units to the left? So that means left has to do with the x, so it's going to be here, x. And then to the left would be negative 7, but since the x, we go the opposite direction. That's going to be plus 7. And 3 units down, it's the same direction, so minus 3. So this would be my function here, and that would be number 1. A little bit tricky. And we look at this one here. Now we're looking at reflections. For reflections, we're going to reflect which is a graph of the following, y equals negative f of x. Okay, so let's pick a point right here. Okay, this is x. So we want y equals the opposite of f of x. So when y equals this number here, well, whatever that is, let's say that, whatever, okay, and then the height of this is right here, so I want y to be the opposite of that, which means it's going to be down here. So it's going to look something like that. And then each of these will be the opposite of this, which will be down here, and it's going to look like that. So that would be my graph. This is the best one. It looks a little bit off, but that's better than any of the other ones. So the opposite, basically the height of this, which is the y, would be, instead of going up, I'm going to go the opposite direction. Okay, now this one's a little different because this, instead of the negative fx, is f of negative x. So y equals f of negative x. This gets a little bit tricky. Okay, so when y equals this number right here, the height of it is going to be whatever the height is at the opposite x, which is down here. So that's going to be down over here. And if I look at a point here, it's going to be the opposite, whatever the x is here, which is down over here. And then if I look at a number here, it's going to be the height of the opposite, which is here, and so on and so forth. And this one here is going to be the opposite here, which is going to be up here, and it's going to look like this. And that would be my answer, which looks like this one right here. No, not that one there, because the arrows are going the wrong direction. It looks like this one here. So what really happens here is when I have y equal, you notice how this would be basically a reflection over the y-axis. And this one here is a reflection over the x-axis. So the bottom line is y equals f of x goes to negative f of x. It's a reflection over the x-axis. This is the x-axis, so the reflection would look something like this. Just a mirror image down that way. Y equals f of negative x. It's going to be a reflection over the y-axis, which this is the y-axis, so it's going to look like this. And that's kind of the basics of what we have there.